basically just did kind of what we call an informal proof. We went through the steps of the solving for x, and then we justified each step with one of our properties. That's what a proof does. You go through the process of solving a problem, and then you justify each movement or each action within the solving of that problem. Those are called proofs. And so with our proofs, we have two columns. We call them a two-column proof. And on our left-hand side, we have our statements, which are going to be mathematical statements. So in our do first, these would be considered our statements. All of the mathematical steps are statements. The right-hand side we call justifications. These are only going to ever be words. There's never going to be numbers on the justification side, only words or letters. When we write our formal proof, our first statement of the proof is always what we call the given. What information are we starting with? If you look over at example 2, just to the right here, we have a given right here. So that's what our first statement is going to be. The last statement is always going to be the prove statement. So I'm going to slide over so we can see example 2. See here, there's a prove. That is always going to be the last statement given. So you should always be given the first statement and the very last statement, and you're filling in the steps in between. So for example 1 here, I'm going to go ahead. My first statement is the given. So I'm going to rewrite this. -5, parentheses x plus 4, plus 10 equals 70. And my prove is the last statement, x equals 16. This is my given. And then my prove is not a justification. The word prove is not a justification, so I'm going to leave that blank. Now, mathematically, I'm going to go through and try to solve this. Now, there are some steps that may go in a slightly different order, depending on how you choose to go. That doesn't mean it's wrong or different from the way I do it. Some of them might be wrong, but some things can be flip-flopped or changed place. So the first thing that I want to do is I personally am going to want to distribute. So I'm going to distribute that -5 inside the parentheses and get -5x. It's a weird little x I just drew, x. -5 times 4 is -20 plus 10 equals 70. And that's distributive property. So now again, I'm trying to get closer and closer to x equals 16. So -x minus 20 plus 10 equals 70. Well, in this, I see that I have like terms. So with those like terms, I'm going to combine them. And that leaves me with -5x, -20 plus 10. -20 plus 10 is going to leave me with -10 equals 70. And that was just simplify. That was just to simplify. One step closer to x equals 16. What is the next type of mathematical process you would do? How would you start to get x by itself? We're then going to add 10 to both sides. So we would get -5x equals, these cancel out, the -10 and +10, and then 7 plus 10 is 80. And that was addition. So the addition property. Now you can always, off to the side, if you need to work out the steps off to the side, like scribble off to the side the math part, you are more than welcome to do that. That is fine. And my last step here, I go from negative 5x equals 80 to just x equals 16. So that tells me I used the division property. I divided. And then we're done. We're done with that proof. I'm going to do one more.